Today on Radio Boat Anchor, I'm going to restore this vintage 1964 Heathkit GR-64 shortwave receiver that I recently purchased on eBay. History. The Heathkit GR-64 was a popular tube-based entry-level shortwave radio kit manufactured by the Heath Company from 1964 to 1971. It was designed for hobbyists, featuring 4-band coverage, 550 kHz to 30 MHz, a 7-inch slide roll dial, and an S-meter. Priced at $37.95 in 1965, it was an affordable, accessible introduction to shortwave listening. I wanted the challenge of a detailed restoration. I found this Heathkit GR-64 receiver with manual in a for parts or not working condition on eBay. I offered the seller $58 plus tax, and the seller accepted. Free shipping was included. I probably overpaid, as I recently picked up a second Heathkit GR-64 for parts or not working condition on eBay for $15 plus tax and shipping. The Heathkit GR-64 assembly manual is essential for servicing and restoring this vintage shortwave receiver. I will include a link in the description on where you could download it in PDF format. Unboxing. My first Heathkit GR-64 receiver with manual came 2 weeks after purchase. Disassembly. The cabinet over the receiver chassis was removed, held in place with 2 screws on the right side and the left. These screws were missing from my Heathkit GR-64. This reveals the internal electronics. I noticed immediately that the dial cord was misrouted. It should go under the tuning capacitor shaft. I used an alligator clip to keep the dial cord in position, while I rerouted the dial cord under the tuning capacitor shaft. The band A antenna rod's 2 connections were desoldered from the printed circuit board. And then 4 screws were removed in order to remove the back panel. Heath Company included an identification label with model and production series with the kit. You would need this information if you called Heath Company for support. Removing the back panel exposed this label as well. The manual does not mention this label. I decided to remove the 4 electron tubes at this point in order to protect them from damage during the restoration process. I placed heat shrink tubing over the tube socket grounding straps to make sure I didn't cut my hands on them. I desoldered the 2 wires from the audio transformer to the speaker, then removed the 2 screws that hold the speaker to the bottom plate. At this point, I moved the band spread dial until the band spread air capacitor's plates were fully meshed so as to protect them from damage during the restoration process. I did the same for the main tuning air capacitor's plates as well. The bottom plate is typically held in place with 11 screws. They were noticeably missing from my Heathkit GR-64. Here is a bottom view of the chassis. Believe it or not, the Heathkit manual specifies running all these bare wires from the printed circuit board to the band switch decks. Bare wires also run to the automatic noise limiter switch on the back of the chassis as well. Electrolytic capacitor replacement. Electrolytic capacitors have a finite lifetime. As they age, the electrolyte dries up, causing their capacitance to fall in value. The Heathkit GR-64 employs a multi-section electrolytic capacitor. It would be nearly impossible to find a direct replacement, present day. In addition, there's an electrolytic capacitor hiding on the inside of the chassis. Replacement electrolytic capacitors must meet the capacitance and meet or exceed the working voltage of the capacitors they are replacing. I installed a terminal strip using an existing screw, then wired the replacement capacitors to the underside of the chassis. I had to wire several modern capacitors in parallel together to get the non-standard capacitance values required. I also made sure I observed the polarity of the capacitor replacements. All electrical connections to the original multi-section electrolytic capacitor were removed. The multi-section capacitor is there for aesthetic purposes only and is not electrically connected. Wiring. The assembler of this Heathkit GR-64 was rather sloppy on soldering the components to the terminal strips, and the uninsulated connections to the printed circuit board were rather sloppily routed as well. I shortened the uninsulated connections and neatened them up. In addition, I shortened and neatened up the insulated twisted pair wiring as well. I also replaced this wire restraint. The original one had cracked with age. Cleaning, lubrication, and contact cleaning. I removed all the front knobs. They were held to their shafts with a single set screw. The front panel was thoroughly cleaned with my go-to cleaner, Windex. Then it was treated to a coat of Armor All to bring back its luster. All the front control shafts were treated to Label 107, a plastic-friendly model train oil. All the knobs were thoroughly cleaned with water, using a toothbrush to get into the grooves. Then the knobs were reinstalled onto their proper shafts. I replaced the band switch knob with a genuine Heathkit one I had in my parts bin. From under the chassis, I oiled the band switch here, the main tuning shaft here, the shaft of the band spread variable air capacitor, the shaft of the main tuning variable air capacitor, and all the pulleys used for the dial pointer cords. Label 106 PTFE grease was applied to the band switch detent mechanism, the bearings of the band spread variable air capacitor, and the bearings of the main tuning variable air capacitor. The power cord was cleaned with a magic eraser pad, then thoroughly rinsed in order to remove any bleach residue. Armor All was used to bring back the luster to the power cord's final covering. Then the power cord was neatly bundled in place with a twist tie. Deoxit D5 was used to clean the contacts of every switch jack and the wiper and contacts of every potentiometer. Checking pilot lamps. Each frosted number 47 pilot lamp is held in place with a single screw. The pilot lamps have a bayonet mount you simply push and twist counterclockwise to remove. I tested each pilot lamp for continuity. They both tested good. The pilot lamps were reinstalled into the sockets, then the sockets were affixed back to the chassis with a single screw. Chassis and printed circuit board cleaning. I used my go-to cleaner, Windex, to clean all surfaces of the chassis. Q-tips moistened with Windex were used to clean hard-to-reach places on the printed circuit board. Here are pictures of the cleaned chassis and printed circuit board, tube testing and installation. I used my trusty ICO 635 tube tester to test the 4 electron tubes used in my Heathkit GR-64. I have had other tube testers and found the ICO 635 to be the most user-friendly. When testing electron tubes, my main concern is with open filaments and shorted elements, such as heater to cathode or grid to plate shorts. I pass electron tubes with marginal performance as they tend to improve with use. I only cleaned the tops of the electron tubes with Windex as the markings on the sides are easily wiped away with cleaning. Each electron tube was installed into its proper socket. The electron tube type is silkscreened next to each socket. For example, the 12BE6 electron tube goes into this socket. The electron tubes in these locations required that the shielding be reinstalled. Initial testing. I placed my Heathkit GR-64 chassis on its side for easy access. I then connected the speaker to the audio transformer with alligator clips. In addition, I connected the band A antenna rod on the back panel to the proper connections on the printed circuit board with alligator clips as well. I then connected power. The antenna rod on the back panel is only connected when in the band A position. An external antenna is required for all other band positions. Band A was picking up broadcasts. I moved my Heathkit GR-64 chassis over to my ham radio desk so that I could connect it to my external G5RV dipole antenna using an alligator clip to the external antenna connection. This allowed me to test B, C, and D bands. One issue that came up during initial testing was that the relative strength meter was less than responsive. Upon doing some research on the internet, I found another restorer had this very same issue with his Heathkit GR-64. The problem was caused by the rosin flux residue acting conductive in the high impedance relative strength meter circuit. I removed the rosin flux residue around V2 or the 12BA6 electron tube socket with a flux remover pen. The relative strength meter was much more responsive after the rosin flux residue was removed. Alignment. The Heathkit GR-64 manual includes an alignment section starting on page 35. Alignment is the process of adjusting a radio receiver's internal components, specifically intermediate frequency transformers, coils, and trimmer capacitors to maximize sensitivity, selectivity, and dial accuracy, ensuring it meets manufacturer's specifications. While this may be an unpopular opinion, I recommend not attempting alignment on a 61-year-old Heathkit receiver if it has moderately good reception. Trimmer capacitors and ferrite slugs this old, used in the alignment process, may be easily damaged, rendering a specific band or in some cases the whole receiver inoperable. I have broken many a vintage radio during the alignment process trying to make it gooder. Assembly. The bottom plate was thoroughly cleaned with Windex, then installed onto the bottom of the chassis, and held in place with 11 6/32 by 3/8 sheet metal screws. The audio transformer's connections were soldered back to the speaker. The speaker was attached to the bottom plate using 2 6/32 by 3/8 flathead screws. The heads of the screws used to hold the back panel in place to the chassis were polished to remove the rust and treated to a coat of clear paint. The back panel was fastened in place using the newly polished screws. The band A antenna rod attached to the back panel was soldered to these terminals on the printed circuit board. The cabinet was cleaned with my go-to cleaner, Windex. Then Armor All was used to bring back the paint's luster. I performed a check to make sure everything was in order on the top side of the chassis. Then the cabinet was installed. It was held in place at the bottom plate with two 6/32 by 1/4 screws on the right side and 2 screws on the left. Conclusion. Here's my newly restored Heathkit GR-64 in action. It is proudly displayed on my computer desk. I often look through old Heathkit catalogs posted online looking for other Heathkit receivers that might be fun to find on eBay and restore. I truly enjoy restoring vintage Heathkit equipment. It reminds me of sitting at the kitchen table as a kid, helping my dad build Heathkits. It was my job to organize electronic parts for him, although I'm not sure how much my parts organization really helped. Please like this post and subscribe to Radio Boat Anchor so that you're alerted to my future posts. Thank you.